So, good afternoon, students. Today we shall see the demonstration of the clamper circuits. Okay, so in clamper, totally you have 4 circuits. The first circuit is clamping at plus 3 volts. Okay, the clamping at plus 3 volts. Next circuit is clamping at minus 3 volts. Okay, the next circuit is clamping, negative clamping. So these two are positive clamping. Okay, positive clamper, that is clamping at plus 3 volts. Next is positive clamper clamping at minus 3 volts. Next is negative clamper clamping at plus 3 volts. And next is circuit is negative clamper clamping at minus 3 volts. So totally you have 4 circuits. Now let us see the output of these circuits. Okay, so before first I will take positive clamper, that is clamping at plus 3 volts. So if you observe the circuit, you have a 0.1 microfarad capacitance which is connected in series with the AC supply, that is signal generator. Okay, so this is positive of the capacitor is connected to this, and another terminal of the capacitor is connected. This is ceramic capacitor we have used. Ceramic in the sense, so this capacitance. Okay, so this capacitance is the ceramic capacitance. Okay, so this is 0.1 microfarad. So this has no polarity. Okay, just it has 2 terminals. Okay, so this is the ceramic capacitance. To the one terminal we have connected to the signal generator. Okay, so in order to observe the input also, I have shorted one more probe here. Okay, so 2 probes I have taken and shorted together. Okay, so positive of V in is connected to the capacitor of one end. Okay, so you can observe here positive is connected to the one end of the capacitor. Okay, similarly the negative is connected to the ground. So all these points are made common ground. Okay, so this is the common ground terminal. Okay, so you can observe this is the signal generator. Okay, so one probe I have taken from the signal generator and another probe from the CRO, that is channel 2. Okay, so both the probes I have shorted here and I have given to the capacitance one end. Okay, then negative terminal of the capacitor to the other terminal of the capacitor, diode is connected. Here you can observe this is IN4001 diode. The negative terminal of the diode is connected to the capacitor. Okay, and this is the positive of the supply. Okay, we have to give plus 3 volts reference voltage. You can observe here this is the reference voltage, we have to apply plus 3 volts. Okay, so positive is connected to the positive of the diode and negative of this to the common ground. Okay, so here negative is connected to the capacitor and positive to the positive of the supply. Okay, just a minute, I will set this to 3 volts. So approximately 3 volts. Okay, so positive of the V reference I have connected to the diode positive, negative of the V reference I have connected to the common ground. Okay, and this node is in turn shorted with this. So this is 100 kilo ohm resistor. Okay, so you can observe here we have connected the load in parallel to this combination. Okay, so I have connected the load from this point to here. Okay, like this load is connected, and across the load output is measured. Okay, so you can observe across the load output is measured. Positive terminal is connected to here. Okay, and negative to here. See, remember that the positive and negative should not touch each other. Okay, you should remember that. Okay, so this is the positive and this is the negative that is given to the channel 1 of the CRO to observe the output. So input is a triangular wave. Here you can observe the input must be a triangular wave. So input I have given the triangular and the output will be like this. It is also a triangular wave without clipping, but you can observe it is shifted above. Okay, see, this is the 0 reference level. This T axis, this is the 0. From 0 it is shifted above to the 2.4 volts. So this much gap will be there from 0. Okay, so the waveform is shifted. Okay, so what do you mean by clamping? Clamping is nothing but the process of shifting the DC level of the input signal above or below the reference level. So this is above the reference level, so we have shifted the signal above the reference level. Okay, so observe here, this is the triangular wave. So this is the triangular wave. In the signal generator, you have to set the signal generator waveform to triangle. Try. See here, this waveform you can change. This is pulse, this is sine, this is square, this is triangle. Okay, and frequency 1 kilohertz. In the manual, I have given that to set this to 20 volt peak to peak. Okay, but in signal generator, if we make the amplitude knob maximum, even though we make the amplitude knob maximum, we can't get the 20 volts. Okay, so I have set this to 10 volts peak to peak. Okay, so how I can set this to 10 volts peak to peak? See here, this is the input channel. So I have set this to 5. So 5 into 2 divisions, 5 into 2, 10. So here you can observe 5 into 2 divisions is 10 volts. So 10 volt peak to peak I have set here. Okay, and above is the output waveform. Okay, above is the output waveform we are getting. Okay, first we shall see the transfer characteristics, or first you have to verify whether the output is in the correct position. Okay, so input okay, input waveform I will remove. Okay, I am getting only the output waveform here. So according to this, according to theoretical, what I should observe? I should observe that the waveform should be shifted above the 0 reference level. It should be 2.4 volts. So above 0 it should shift to 2.4 volts. Okay, so this negative peak should be at 2.4 volts. Okay, how to check that, how to observe that? See, this is the output, this is the output knob. Okay, this also I have kept in the same division, that is 5. Here also 5, here also 5. You should keep it in the same divisions. Okay, so this is 5. Okay, so now I have kept it in the 5. Okay, and I will press the DC button. Okay, you have to press the DC button. Okay, because the DC shift should be provided, so you have to press the DC knob. Okay, if it is not pressed, it will be in AC. Okay, if it is pressed, it will be in DC. Okay, next I will press the ground button. I will press the ground button. Okay, and I will set this to this reference level. Okay, so I have set this to the reference level. So this is my 0 reference level now. Okay, this is my 0. Now I will remove the ground button. Okay, so what happens, you can observe it is the waveform is shifted above, right? So how many divisions it is shifted? See here, this is 0. Okay, so this is 0.2, so this is 0.4. So point negative peak is approximately 0.4. Yeah, you can observe it is at 0.4. So 0.4 into 5, how much? 2 volts. Actually we have to get 2.4, but practically we are getting 2 volts. Okay, there will be some difference between the theoretical and practical values. Since we are dealing with the analog components, we will get some difference. Okay, due to the components error, we get some difference. Okay, so instead of 2.4 we are getting 2, which is approximately 2.4 only. Okay, and the total peak you can observe. If you observe the total peak, you should get, see here they have given the input 20 volts, but I have given the 10 volts peak. Okay, since in the signal generator it is not possible to give 20 volts, I have given 10 volts peak to peak. Okay, so for 10 volts peak to peak, for 10 volts peak to peak, so 2.4 volts the waveform should shift above the 0 level. So remaining must be 10 volts, right? So the remaining from negative peak to positive peak, it is 10 volts. So 10 plus 2.4, how much? 12.4. So this positive peak from the 0 reference should be 12.4. Okay, let us check that. See, observe the waveform. So this is the reference. Okay, from here this reference to total peak, it is 0.4. So this is 1 division, this is 2 division, 2.4. Okay, so 2.4 into 5, how much? 2.4 into 5, it is 2.4 into 5, 5 4s are 20. So it is approximately 12 volts only. You are getting approximately 12 volts only. So that is how you need to calculate whether it is clamping at the correct levels. Okay, so now I will get both the waveforms. I will display both the waveforms, that is both input and output waveforms. Next I have to get the transfer characteristics. See, this is the transfer characteristics. Okay, so this is the transfer characteristics. Okay, so how to obtain this transfer characteristics? Let us see. See, to obtain the transfer characteristics, always you should remember that the input should be given to the channel 2 and output should be given to the channel 1. Okay, it should be vice invert. Okay, for channel 2 input, for channel 1 output. Okay, so how to obtain the transfer characteristics? As I explained in the clipping circuits, press the ground buttons of both. Okay, press the ground buttons of both and bring both the lines, reference lines, to one axis. Okay. So like this, you bring both the lines to the one reference axis. Press XY button. Okay, so after pressing XY button, you will get a dot. Okay, single dot here. So you should bring this dot to the exact center of the axis. Okay. Okay, so you can observe it is exactly the center of these two lines. Okay, this center point exactly at the center. Now release XY button. Ground button should be pressed. Only you have to remove the XY button. Sorry, remove the ground buttons. Okay, so this is the transfer characteristic you will get. Can you observe the transfer characteristics? Okay, so in the transfer characteristics, you can observe it is not like a single line as you observe in the ideal characteristic. In ideal characteristic, you observe it as a single line, but in practical, it is not a single line. You will get two lines like this. Why you are getting two lines? Because you have observed that the ideal output value and the practical output value is different, so you will get both. There is a difference. Instead of 12.4 we are getting 12, and instead of 2.4 we are getting 2 volts. Okay, so that much difference is there, so two lines will come like this and you will get the transfer characteristics like this. Okay, so both input and output will not coincide. Okay, if there is some difference. Okay, so this is the transfer characteristics. Here also you can observe it is above 2.2 to 0.3 sorry 0.4. Okay, 0.4 into 5 it is 2, so it is shifted at 2. Okay, at 2 volts. Okay, and if you observe from the here this is one division, this is two division, this is how much, 2.2. okay, 2.2 into 5, it is approximately 12 volts you will get. Okay, so like this, see, this should be at 2.4, this is you are getting at 12, like that. In between also you can calculate where this meets this point, that also you can calculate. Okay, so in this way you need to calculate the you need to observe the waveforms as well as the transfer characteristics. Okay, so next circuit is just you need to reverse the diode and the polarity of the supply. Okay, so if you compare the positive clamping at +3, see, this is the positive clamping at +3 volts. Okay, here you can observe the diode polarity is like this, negative positive, which is same in the positive clamping at -3. Okay, the diode polarity remains same, but the reference voltage, so this is positive, this is negative. Okay, So but here you can observe negative is connected to the positive and positive to the negative. Okay, so only the polarity of the reference voltage reverses. Okay, so if we reverse the polarity of the reference, you will get -3 here. If it is positive towards upside, it is +3. Okay, that is the only difference between positive clamping at +3 and -3. So now I will just change this polarity and I will show you the curve. So negative should be connected to the positive terminal of the diode. Okay, and this positive uh, I will connect to the ground. So you can observe here, this is the positive I have connected to ground, whereas the negative I have connected to the diode positive point. Okay, just I have reversed the polarities of the reference. Okay, so everything is same, just you need to observe the waveforms. So let us see the transfer characteristics. See, if you observe the transfer characteristics, so this is the transfer characteristics of the positive clamper clamping at negative um, uh, clamping and clamping at -3 volts. So you can observe this curve should come below the reference. Okay, so it should come below the reference. Here also you can observe, so it is coming below this reference. Okay, so this is the VI characteristics. Okay, so you can measure that. Yeah, it is 0.6 into 5, 3 volts you are getting, right? 0.6 into 5, you are getting 3 volts. Okay, so here you can observe 0.2, 0.4, 0.6. So 0.6 into 5, 3 volts. So actually you should get 3.6 minus 3.6. How? In the sense, this is -3 minus 0.6, 3 -3 minus 0.6 is -3.6. So you are getting -3.6. Like this you need to calculate the clamping value. Okay,